Now, multiplexing, there's different types. There's frequency and there's TDM, which is time division. And time division can actually be synchronous or asynchronous. And in this domain, we talked about the difference between synchronous communication and asynchronous. Synchronous means that the sender and receiver are synced up, meaning that they know how they're going to communicate, and there's basically just going to be a clocking pulse that will say, okay, we're going to start now. Now, asynchronous is not, the two sender and receiver are not synced up, so they actually have to use a start and a stop bit. So we went through those concepts earlier in this domain. Now we're going to go through the actual multiplexing, how that takes place. So TDM, as I said, that you can actually, a device can have a slot assigned to it, and if it doesn't have anything to say, then that slot just goes empty. So that can seem a little bit wasteful, but it happens so fast. There's not like latency that's very easily detected. But because that is a little wasteful, you know, if something doesn't have anything to communicate and it continually sends over this empty slot, there's something else that's called statistical time division. And what this type of multiplexing does is it keeps statistics on how different devices actually, how much data they send over. So, and it's going to dynamically create that slot based on what was sent before. So for example, let's say you have a plotter, a printer that's going to send an amazing amount of data. Well, if it only had to go in these time slots, that would take a long time to get the whole graphic or whatever's going to be printed over to the destination. But in statistical time division, the multiplexer can dynamically create how big that time slot is going to be. And it's not going to be like, oh, here comes a whole bunch of data, it better have a really big slot. It's based on statistics of what's happened before, and it'll use that information to determine what type of time slot this type of device actually needs. Now, the frequency division multiplex is different. It's going over spectrum radio signals. And instead of the time division where you have specific blocks cut up, what FDM does is it has a specific spectrum and each signal is working at a different frequency. So you can have one frequency, this is where you move your voice data. Another frequency, this is where you move your data. Another frequency, this is where you move your video data. So frequency time division just means that it's going to go over some type of wireless. You have a spectrum, and each spectrum is assigned to something, either a device or a type of data that is going to go to the destination. So in this situation, computers don't communicate in analog, they communicate in digital. So your digital communication, your digital data is going to be modulated into a signal at a specific frequency, and then it's going to be sent over to the multiplexer at the other end. That multiplexer will then change that analog frequencies into the necessary digital encoding so that those computers can understand it.